How we doing today? This is Mr. Novak, and for today's notes that we're going to be taking, we're going to be learning about acceleration for math notes. So we've kind of already learned about acceleration in terms of examples, in terms of increasing speed, decreasing speed, and changing direction. Now we're going to kind of apply what we learned about acceleration in kind of a more math setting. So we're going to kind of use some numbers to kind of figure out what acceleration is. Okay, so let's take a look here at our problem. Okay, so our formula for acceleration is the final velocity minus the initial velocity divided by time, or it can also be written as A equals VF minus VI divided by T. Those are the same things. They're just written in a different way. So sometimes when it's abbreviated, you'll see VF minus VI, and that's just saying it's the final velocity minus the initial velocity. Just a reminder, when you see that word initial, okay, when we see that word initial, it's the same thing as saying the start, right? Something that's at the start or the beginning. So it's what number would be coming first, right? What velocity is the object or person or whatever you're measuring, which one's coming first. Okay, so as we do this, just like kind of how we did our speed problems, we want to see what our all our labels are, what are all our different variables, and then we kind of plug them in, and then that helps us solve the problem. Okay, so let's take a look. So a car accelerates from 0 meters per second to a speed of 40 meters per second in 2 seconds. So what is the acceleration of the car? So let's take a look. Let's underline our numbers. So we have 0 meters per second, we have 40 meters per second, and we also have 2 seconds. Okay, so if we take a look at this first, so the first thing is, as I'm looking for, is we're looking for our final velocity, okay, and our initial velocity. So it says a car accelerates from 0 meters per second. So that's telling me that's the start, right? So the start is, right, if we look at start, that's initial. So I'm going to put a VI for this one, okay, because that's what we're starting with. Then it changes, right? It goes from 0 to 40, okay? So that's going to be our final speed or velocity, okay? And then in 2 seconds. In 2 seconds, right, as we've kind of done before with speed, seconds, that's a unit of time, so we're going to label that T. So I'm just going to fill that in over here. Okay, our final velocity was 40 meters per second. Our initial velocity was 0 meters per second, and our time was 2 seconds. Okay, so I'm going to write our formula. So it's A equals VF minus VI divided by T. So our final velocity minus initial velocity divided by our time. So as we plug it in, our final velocity is 40 meters per second minus our initial velocity, which would be 0 meters per second, and all of that is divided by T, which is 2 seconds. So what I'm going to do is I'm just going to subtract, right? So what's 40 minus 0? That's just going to give us 40. So we have 40 meters per second divided by 2 seconds. Okay. Let me just extend the page here. Okay. So if we look at this, then we just do, this is all we're solving for A, right? A equals 40 divided by 2 is 20. Okay, and here's the key here of when we're labeling this. Okay, much like when we're dealing with velocity, remember velocity or speed was always that label or unit, right? It always had to include two things, right? It had to include a distance and a time, right? So if we look at this, meters would be like our distance and this would be our time. Okay, so we still have to include that in our label. So I'm going to put 20 meters per second. And also, if you notice, right, this is divided by 2 seconds, okay? So since it's divided, we're going to add, we have to make sure that unit is included as well, which would be seconds. So we could write it like that, 20 meters per second per second. So what that tells us, every second, the speed or velocity of the car is changing 20 meters per second. That's the speed of it, okay? So this is how it's labeled. So you always want to include, you're including all the units. Okay, you're going to include the velocity unit, and you're also going to include the time unit as well. Okay, and our last one that I wanted us to kind of take a look at, very similar but also a little bit different. And this is kind of the other way of you can kind of see it. So if we take a look, we have a car accelerates from 60 meters per second to a speed of 10 meters per second in 5 seconds. So what is the acceleration of the car? So again, we're gonna underline our numbers here, our units. Okay, so then we're going to start with this, right? So a car accelerates from 60 meters per second. So that's what the car is starting at. So that's going to be my VI. It's going to be my initial velocity. Okay. Then it changes, right, to a speed of 10 meters per second, right? That's what it's going to end up at. So that's going to be my final velocity, and my 5 seconds is going to be my time. Okay, so let's plug these in. My final is 10 meters per second. My initial is 60 meters per second, and my time is 5 seconds. Okay, so let's rewrite our formula from up here. So we have A equals VF minus VI divided by T. Okay, so let's plug it in. So my final is 10 meters per second. Then I'm going to subtract minus my initial, which was 60 meters per second. Okay, and I'm going to divide by 5 seconds, which is our time. So if we take a look at this, if I do 10 minus 60, okay, 10 minus 60, I'm going to get a negative number, and that's okay. Remember how we talked about acceleration? Acceleration can be an increase in speed, and it can also be a decrease in speed, so it can be negative. So if I do 10 minus 60, right, I put that in a calculator. Remember, it's important to make sure I put the 10 first, and then I put 60 second, right? So I do 10 minus 60, it's going to be negative 50 meters per second, okay? And I'm going to have to divide by 5 seconds, okay? So let's bring it down here, extend the page. So my acceleration, right, I do negative 50 divided by 5, and it's going to be negative 10. And I'm making sure I'm going to include all my labels, right? So meters per second, right? That's my velocity, and also I need my unit of time, right? Seconds. So meters per second per second. Okay, it's very important. That's probably the trickiest thing when we're doing acceleration problems, is to make sure that you're including all of your units and make sure the unit is labeled properly. Okay, this is Mr. Novak signing off. Have a great day.